Hello guys. So let us begin with a new video on the classification of climate by Koppen. Before that, I'd like to tell you all that I had completed the nuances of air pressure and distribution of pressure. So those of you who wish to do the next topic on the wind circulation, I have already uploaded a video on the Coriolis effect, wind circulation, and wind belts of the earth. So I am not going to repeat that full course, but if you wish to ask anything or if there is any doubt or question, you can ask me separately. Also, a suggestion is that since that video is of my class lecture, so some of you might find the audio not very clear. For that, I would request you all to use the headphones so that you don't have any problem in listening to what I have said. All right, so let us begin. The today's topic is Copens climate classification. Now, this is a very not so technical topic, but questions are always asked. One or two questions always come, and if you go through the book, you might find it a bit confusing as to how to remember the classification of climate. Several classifications have been given. Most common ones, they include the Copens classification, then there is Trevartha's classification, okay, then there is Thornthwaite's classification, but today we will be doing the Copens classification. Now, Vladimir Koppen, he was a German botanist and a climatologist, and his classification scheme was given as early as 1900, and he himself revised the classification scheme several times during his lifetime. He was never satisfied with his classification scheme, so he kept on adding a lot of things. And in 1970s, 80s, a few more scientists, they added a lot of information to it, and this Koppen's climate classification scheme was modified and to be known as Koppen-Geiger classification scheme of climate. So let us see what was Koppen's climate classification scheme, what was the idea behind it, and how do we identify the different zones which fall in different types of climate groups as given by Koppen. First of all, the classification scheme by Koppen was very much, motivated by the vegetation classification given by Candola in 1874. As I had just mentioned, that Koppen himself was a botanist, so it's quite obvious that he will have his first uh, inclination towards the classification of plants and the way they are done. So if we look at this Candole's scheme, which was given in 1874, he classified the plants or vegetation based on the requirement of temperature and moisture in five groups: megatherms, xerophytes, mesotherms, microtherms, and hecistotherms. So megatherms, they are those plants which require high temperature and high moisture supply. So we can understand that these plants would be following those zones where the seasons, they will be warm and humid. So warm and humid seasons, that is why those seasons are winterless. Average temperature of the coldest month is more than 18 degrees Celsius, so you can imagine how much heat there uh, is readily available always. Precipitation is very heavy, and therefore the typical megatherms, they are tropical rainforest. So when we talk about the tropical rainforest and we follow the uh, latitudinal distribution, then we can very easily understand that this type of vegetation, the megatherms, they are restricted to the equatorial and tropical zones, means extending from 15-20 degree north to 15-20 degrees south, including the equator. Okay, these are those areas which receive maximum amount of heat and temperature and precipitation. Next is xerophytes. As the name suggests, Xerophytes, we all have studied in our lower classes that these are the desert vegetation. So arid climate with high temperature. So here the climate is very dry, arid, and the temperatures obviously are very high. So when the temperature becomes very high and no moisture is there, it becomes arid. It has semi-arid steppes and hot deserts. So uh, if you see the video on the wind circulation, then you will come to know that the latitude between 25 and 30 degree north and south means typical where the sinking arm of the headless cell comes down. There we find the deserts. These deserts, they are formed at approximately 30-degree latitudes in north and southern hemisphere because the sinking air is devoid of moisture, and as this air is devoid of moisture, there is no rainfall, and therefore the xerophytic plants are there. So how do we identify xerophytes? They are normally the plants which have uh, thorn like leaves, very fine, very small leaves, so that they can sustain and preserve their moisture. Next is the mesotherms. They require moderate heat and moisture, and normally they are the subtropical latitudes between 22 and 45 degree north and south. So here they have moderate heat, moderate moisture. Average temperature for coldest month is less than 18 degrees Celsius, while the warmest month is approximately 22 degrees Celsius. The microtherms, they are the lower mean values of temperature, cool and short summers. So, cool and short summers and colder winters. Now we are entering the temperate region. So, we are entering the temperate zone. This temperate zone, it has the monthly mean temperature for warmest month at least 10 degrees Celsius. So the warmest month there is 10 degrees Celsius, while the coldest month it has a temperature less than 6 degrees Celsius. And here we get evergreen deciduous forests and steppes. And the last one is hecistotherms, which is typically polar vegetation, subpolar polar vegetation, snowbound Arctic region, and therefore they have mosses and lichens as the main vegetation. So if we look at the map of the world, we can easily distinguish the latitudinal extent. So if we see megatherms, you can see the megatherms are from 20 degree north to 20 degree south, including the equator. This zone is the megatherms. The xerophytes, 20 to 30 degree latitudes, they have xerophytic plants. Then mesotherms, 25 to 45 degree north and south latitudes, they are mesotherms. Then we have this temperate region as microtherms, and the polar region as hecistotherms. So this latitudinal extent of this vegetation, it gives us an important information about the temperature and precipitation, and these were two statistical parameters which were chosen by Koppen to give his classification scheme. Now, what is the advantage of Koppen's classification scheme? He uses temperature and precipitation in his classification, and this makes it important because these two parameters are very easy to measure, and therefore this classification scheme designates very precisely each climatic region. The Copens classification scheme is also based on the relationship between plants at a particular place and the climate. So whenever we talk of climate in terms of plant, it means we are talking about the temperature and precipitation. So he uses this relationship between plants and the climate, and therefore his scheme uh, is very easy to understand. So let us see what is his scheme. Koppen's scheme, also referred to as Koppen-Geiger climate classification scheme, divides climates into five main groups, each denoted by an alphabet. So A, B, C, D, E. A is A is humid tropical climate, B is dry climate, C is warm temperate rainy climate or humid mesothermal climate, D is humid microthermal climate or cold snow forest climate, and E is polar climate or alpine climate. Of these five classes, all except B have been grouped on the basis of temperature, while B has exclusively been classified on the basis of precipitation. So, why do we say that? Because we all know that deserts, they are of two types: hot deserts and cold deserts. So, it means that in case of dry climate in the group B, not only temperature, because here if a few examples like Thar Desert, Sahara Desert, they are all hot deserts, while the deserts like Gobi Desert of Mongolia, then Ladakh, all these are cold deserts. They have extremely low temperature, but due to the lack of moisture, they do not have any vegetation. So they are very, very dry climate. Therefore, if we see here, then A, C, D, and E are typical groups which have uh, the classification based on temperature, while the B group, it is typically based on precipitation. Okay, so how it has been divided? Now, the first alphabet in this scheme is the climate group. Second alphabet, it is the seasonal precipitation type, and the third alphabet is the level of heat. So this scheme is modified and used as the need is. So the first group, which is A, the climate group is humid tropical climate. So if we say tropical climate here, we do not need to take into account the level of heat, because here we all know that the in the tropical climate the heat will always be high. So here we are now going to see the seasonal precipitation type. The second alphabet for A, group A is F stands for rainforest, M stands for monsoon, W stands for dry winter savanna, and S stands for dry summer savanna. So if you read about savanna, savanna is a type of grassland which has huge trees as well as the grassland. So the savanna is a very extensive grassland and by vegetation biome which has forests as well as the grasses. So to remember it, F stands for forest, so you can relate it with uh, rainforest. Then M stands for monsoon. So if somebody says that AF means A is humid tropical climate and F stands for forest means rainforest. So we are talking about the climate zone which falls in humid tropical region and it is a rainforest. Similarly, if it is AM, so it is humid tropical region affected by monsoon. So once we will discuss monsoon, you will understand that monsoon is simply seasonal reversal of wind pattern and typical to the Indian subcontinent and the Asian region. Then if we talk AW, it means that we are talking about the regions where winters are dry. So the places where winters are dry in the humid tropical climate, then they will be classified under AW. And then the regions which are written as AS, so it is a humid tropical climate where the summers are dry. So we can understand that dry winter and dry summers, they are typical due to the uh, seasonal precipitation type. The second climate group is the dry climate, the desert type of climate, or the xerophytic plants where they survive. So B stands for dry climate. Here, as we had already discussed in the previous slide, that the deserts can be warm, hot desert, or cold desert. So we can have two types of schemes for the seasonal precipitation type. If it is a completely arid situation, so it will be W for desert, capital W for desert. And if it is capital S, it is steppe. Steppe is also type of biome, which is a grassland, but here you will not find trees. You'll find extensive grasslands over here, only short shrubs and small grasses. And then if it is small h, it is hot, and k stands for cold, which is the third alphabet, the level of heat. So if we have notation like b w h, it means that we are talking about the dry climate of a desert which has hot temperatures, and BWK stands for dry climate of desert with cold temperatures. I hope you are understanding this. The next climate group is warm temperate rainy climate or humid mesothermal climate, which is denoted by the letter C. So warm temperate rainy climate can have dry winters, which is denoted by small w. So if you see here, the small w in both the cases relates to dry winter, even in tropical humid climate and in the temperate climate. So if it is a small w, you have to understand that it is for dry winters. F is no dry season, so it is always wet, and S is dry summer. So both the cases, S stands for dry summer. Okay, now in this case of group C, the third alphabet for the level of heat is ABC: hot summer, warm summer, and cold summer. So since it is temperate region, we can understand that the temperatures here will be normally cold. So in case of those regions which fall in the in the temperate zone, but they may have hot summer, they can be written as CWA. If we find such type of an scheme, then we can understand that this belongs to the warm temperate rainy climate where humidity will be there, but the winters will be dry and summers will be warm or will be very hot summers. We'll discuss this in detail. Then CWB means warm temperate rainy climate with dry winters and warmer summers, while CWC will be warm temperate rainy climate with dry winters and cold summers. So this is how we can understand. Next is D, humid microthermal climate or cold snow forest climate. So here again we have the same classification scheme as in the case of C, but one thing we will be adding here in the third alphabet, that ABC stands for hot summer, warm summer, and cold summer respectively, but here we add D as very cold winter, because now we have gone to a cold snow forest climate regime. So here the winters will be very severe. And the last scheme is E, the polar climate or alpine climate. Here we can have two types of vegetation patterns based on the seasonal precipitation, that is tundra and frost ice cap. So tundra is T. So if somebody writes ET, it means that we are looking at the tundra vegetation of the polar region. And if it is EF, so it is permanent ice cap. So normally we will not get any type of vegetation in EF zone, which is polar climate, and permanent ice cap, which is normally the Antarctic region, and sometimes the Laurentide ice sheet region of the Arctic. So having discussed this climatic division of Köppen, let us have a look at each of them one by one. So this is the map of entire classification scheme. This classification scheme divides the entire globe latitudinally for the different types of climate. So if we talk in terms of climate for Indian subcontinent, we can see, as the color scheme suggests, that we have AWAS, AM, that is tropical, humid, and monsoonal scheme. Then AWS is dry winters and dry summers. Then we have the BSH. So if you can see here, BWH, which is the regions of Rajasthan and Kutch. Then we have BSH, that is the dry type of climate. Then in the northeastern part and the Himalayan region and all, we have the group C climate, or the CWA and CWB we might have. Okay, so in Indian subcontinent, we have these four or five types of Köppen climate groups that we'll see later. So this map is typical. If you have to remember how to do this map, so start from this. Sorry, start from here. A, which is the uh, warm, humid climate, and write A at the equatorial or low latitudes. Then we all understand that till what latitude uh, the climate will be warm and humid. So it will be typically 20-degree north and south. Of course, see the local uh, landmass pattern and local factors, they do affect the climate, but global scheme is divided typically latitudinally. Next is B, which is the dry climate, and we can see here 30-degree north and south latitude. See, all these are the typical uh, groups which are typical regions which are having the dry climate. Okay, B. Then comes C, which is the humid mesothermal. So now, if you remember, it was warm, temperate type of climate. So between 30 and 45. So this is group C. Then we get the group D, which was the microthermal type of climate, and this is E. So here we have, this is C, this is D, and this is E. So if you wish to remember it easily, simply keep in mind the word map and start going from A to E, from equator towards the poles, and you will easily get all the climatic zones. So the group A, that is the tropical climates or the megathermal climates. So for any climate to be classified under group A, the average temperature of coldest month should be 18 degrees or higher. Now AF, if you remember, AF was the rainforest. So AF is all the seasons are wet or constant rain. So every month has 60 millimeters of precipitation or more. Now, in this case, you will have the constant rains. Then AM was the monsoonal type of climate. So it has very short dry season, and precipitation is in driest month is less than 60 mm. So the normally the precipitation is more than 60 millimeter, but the month which is most dry, then there the precipitation shall be less than 60 millimeter, but greater than, but equal to or greater than 100 minus total annual precipitation in millimeter divided by 25. Next is AW. So AW was the dry tropical savanna. Okay. So here it was the dry winter. So well defined winter season. So winter seasons here are dry, and precipitation in the driest month is less than this value, 100 minus total annual precipitation in millimeters by 25. And AS is well defined dry summer season, but it is quite rare. But in some locales you will be getting the AS type of climate as well. So in this map, if you see, the AF is the dark blue, which is located in the interiors of the land masses, the continent. So in this area, the Amazonian forest, the Central Africa, and the entire Indonesian islands. If you see over here, they are the typical locations of the AF or tropical rainforest, because this is the region which receives maximum amount of rainfall. This is also the region where the ITCZ fluctuates and lot of rainfall happens over here. This is also the zone of convergence of trade winds. Plus, the ocean currents, the warm ocean currents, they flow through here and they add to the moisture content. Okay. So if you look at the rainforest, this map separately, every month has a precipitation of 60 millimeter or more. So you can imagine that why this region. So if we see over here, Then this is a typical Western Pacific region, which the heat over here supplies a lot of moisture. Then in this particular case, the uh, winds, they bring in a lot of moisture from the tropical Indian Ocean, and here the Atlantic and the Pacific Ocean, they throw in a lot of moisture, so we get the uh, tropical rainforest, which is AF. Then dry winter savanna. If you see over here, the regions, if in the previous map, there were particular some locations which were rainforest. Now here, the winters, they uh, become dry. So these areas, they have well defined dry winter season, and precipitation in the driest month is less than 100 minus total annual precipitation. So if for a particular location the total annual precipitation is, let us say, uh, 50 millimeters, then for it to be classified into AW, it should be 100 minus 50 by 25. So this becomes 98 millimeter. Now, if the precipitation is less of the driest month is less than this, it's just a hypothetical example. If it is less than this, then it can be classified under AW. The common examples of Indian subcontinent, they are Chennai, Hyderabad, Kolkata, and Mumbai. The winter seasons there are dry, and they have typical savanna type of climate. Means if you look at the savanna grasslands, you will find that the precipitation normally over there is high. Normally, but once the winter season creeps in, then it is substantially dry season. Okay, all right. The AM, or the monsoonal season, here the precipitation in the driest month has to be less than 60 millimeter, but equal to or greater than the same formula. Common Indian examples are Trivandrum and Mangalore. So if you see over here, the west coast of India, it is a typical AM type of uh, climate. So whenever we are talking about the monsoon, we typically understand the southwest monsoon, which brings in a lot of moisture to this region. Apart from it, again, if you see over here, this zone is restricted to the tropical latitudes, which is a short dry season. In the monsoonal period, in the monsoonal zone, the drier period is very short. Normally the rainfall is very high. Okay, the next group is the group B, which is dry desert and semi-arid climate or xerophytic climate. So here the evaporation has to be higher than precipitation. In case of B, the evaporation has to be higher than precipitation. So it has two types of subgroups: BS, which is semi-arid climate or steppe, and BW is completely arid climate, or it is a desert. The BS is to BW boundary. So where this boundary will be located, how do we calculate that? We calculate it as half of the threshold value. So what is threshold definition? That when in the months of April to September in northern hemisphere and October to March in southern hemisphere. So we all know that April to September are the warmer months of the northern hemisphere. At the same time, those months are the colder months for southern hemisphere. And which are the warmer months for southern hemisphere? October to March. So if during that time we get 70% or more precipitation during the warmer 6 months, then the threshold will be T multiplied by 20 plus 280. In the DS Lal book, you will find this value as a bit different. Don't get confused, because these values have been revised, and you might end up confusing. So if you look at the DS Lal book on the page number 325 in the classification of climate, the table is given where it is written as RT plus 28 when 70% or more of rain falls in warmer 6 months. So here in this slide, I have given that the annual precipitation is given in millimeters, while in DSLR the formula is based on the annual precipitation in centimeters. Plus, the formula is a bit modified in my slide. It is given as different in the DSLR book. So don't get confused. They call it as the uh, dry humid boundary. Here it is called as threshold definition. So you can follow any of them. Just take care that once you take the precipitation in centimeters, you have to do it as RT plus 28, not 280. While in case of millimeters, it becomes 280. So the threshold definition is that when 70% or more precipitation is during the warmer 6 months, then T into 20 plus 280, half of this value will be given as the BSBW boundary. When 30% to 70% precipitation is received during the applicable period, then it will be added with 140. And when less than 30% of total precipitation is received, then it is T multiplied by 20 and half of that. So if the annual precipitation is less than 50% of this threshold value, then the classification of climate is BW or arid. If it is in the range of 50 to 100%, it is BS or semi-arid. So in case of arid climate, desert climate, you will get cactus-like vegetation, while in case of semi-arid climate, you will get steppe-like vegetation. So see this map. In this map, you can very easily see that all those zones. So if I try to draw the wind circulation pattern over here, so if you see over here, the Hadley cell, so from the equator, the wind rises, goes to tropopause, travels, and then sinks and returns back, right? So this is how Hadley cell functions. So you can see here that this is the zone where the sinking arm of the Hadley cell operates. The sinking arm means there is no moisture at all. So all this zone in this latitude, it will be arid or dry. Okay. Apart from this apart from the wind, there the arid type of climate is also supported by the cold or the eastern boundary currents. So if you see over here, there is a cold current. Here it is a cold current. Here it is a cold current. Okay. Here it is a cold current. Here it is a cold current. So all these factors, they add to the aridity or the dryness of the climate. So here BWH and BWK. So the dark red is uh, we have the dry climate with desert type and hot or warmer temperature. So average annual temperature is 18 degrees or more. And cold arid desert with annual temperature less than 18 degrees Celsius. So you can see here that the Gobi Desert of Mongolia and this region of the Central Asia plus the Southern American subcontinent, all these are those regions which have desert but they're cold deserts. Okay. So it is arid, hot, and desert. So common Indian examples, Western Rajasthan and Kutch. You can see over here in India, we get this type of climate. While the cold desert, as I have just mentioned, the in India we have this Leh Ladakh region over here. You can see they have BWK type of climate. While the Thar desert, the Run of Kutch, they have BWH kind of climate. The next is BS or semi-arid steppe climate. So if you see over here that they have the average annual temperature of 18 degrees Celsius or more, while BSK is arid desert climate with, sorry, this is semi-arid. This is not arid. This is semi-arid desert, semi-arid steppe climate. Let me just correct it for you. Otherwise you get confused. So this is semi-arid steppe climate, Yeah, now there will be no confusion. So, semi-arid steppe climate with average annual temperature less than 18 degrees Celsius will be BSK, and BSH will be semi-arid steppe climate with average annual temperature at 18 degrees or more. So, if you see over here in this case, again the central or the mid-latitude regions, they have the semi-arid type of climate, and BSH, which is the semi-arid with annual temperature more than 18 degrees. If you see over here, we have parts of Gujarat, central India, and the peninsular part of this place. Plus, we have the regions like that of Punjab, the uh, Delhi region, Rajasthan. All these are the places which have BSH. So they have semi-arid steppe climate with temperature more than 18 degrees Celsius. Okay. Now the light yellow portion in this is BSK. So common Indian examples for the BSH is Jodhpur, Kurnool, Warangal, parts of Punjab, and Kutch. So this is the semi-arid climate, steppe with hot temperatures. And the uh, BSK, which is the semi-arid desert with annual temperature less than the 18 degrees Celsius. So this won't be, I'm sorry, I just did some mistake over here in writing it. It will be semi-arid steppe climate, not desert. Semi-arid steppe climate with annual average temperature less than, yeah. So the northernmost portion of India and Kashmir, it shows us this type of climate. Okay, BSK. All right, so I think for this video we can stop at group A and B because too long topic, and we can continue this further.